Hello again, everybody, and welcome to another Geo-Institute live stream. Today, we bring you the 5th episode of this year's GeoStrata Extra. My name is Brad Keeler. I'm the director of the Geo-Institute, and thank you for joining us this afternoon as we go behind the article. If you don't know anything about the Geo-Institute, after you watch this interview today, you should head over quickly. Don't do it slowly. I don't think it'll make a difference, but you should do it quickly to geo-institute.org, and there you will find out all kinds of things about us, including that we are a technical society with about 12,000 members, most of whom are geotechnical engineers and or geologists, and that we are part of the American Society of Civil Engineers. And if you like what you see today, and GeoStrata Extra is always a gem, you are going to like it. You should click like, subscribe, and get notifications, and we will let you know every time we post something to the YouTube channel. 2 brief announcements before we get going today. We are officially in year 2 of our student fund endowment campaign. What that means is that it is year 2 where we are trying to raise $500,000 to match the donation that Jean-Louis and Janet Briot gave us last year, so that we can permanently, I guess you can't temporarily endow something, but so we can permanently endow our student programs. If you would like to make a contribution, just visit geo-institute.org, click on Student Participation Fund. You'll go to the page, it lists all the thank you gifts and everything, and the thank you gift that you can't be without this holiday season is the Ralph Peck bobblehead. Make a contribution of $96 or more, and it will come right to your mailbox. The other thing I want to point out is that if you go to readgeo.org, you will get a page that looks something like this. And you will see the current issue of GeoStrata there before your very eyes. You can click around and see all the different content in the current issue, including the article that we are going to be talking about in just a few minutes, which is right here. Why would you not want to do that? You can go to the issue library and check out back issues that go all the way back to 2017. And this is free and open to everybody. So after you watch the interview today, you should go read Xiaoyan's article as well. Read some of the other content in the magazine. We're really proud of it. It is our 25th anniversary for GeoStrata. You'll enjoy it. I guarantee it. Now, our feature presentation. This current issue, all about offshore geotechnics, as you just saw there a moment ago. We're going to talk offshore foundation geotechnics today. And here to tell you a little bit more about it is GeoStrata editor extraordinaire, Ken Fishman. Ken, tell them what they're going to see today.
Thank you, Brad. I'd like to welcome Cheyenne Long, who has one of the authors on the article Offshore Foundation Geotechnics, Current Technologies and the Latest Advancements. Cheyenne has several co-authors, and these include Komen Chuck, Aaron Broughton, Charles Albany, Robert Stevens, and Lawrence Susanathan. We're going to start with a little summary of the article. Cheyenne has several slides that she's going to show. So I'm going to turn this over to Cheyenne for a few minutes, and we're going to get a brief overview of what's included in the article and what we're going to be discussing today.
Sure. Thank you, Ken, for the introduction. So can you please tell me whether you can see my screen?
I can see your slides that are full screen.
Okay, thank you. Yeah, so first, like on behalf of all my co-authors, we would like to thank you, like the Geo-Institute and also the GeoStrata editorial board, giving us the opportunity to talk about the current technologies and also the latest advancements of the offshore foundation geotechnicals. So basically, like in summary, offshore foundation design and installation is a complex process. So it requires a thorough understanding of the site condition through the geophysical and the geotechnical site investigation and also ground model development. Also, we need to have like the right selection of the foundation types, and then to utilize the special installation equipment to be able to place the foundation underwater below the mud line. So typically, like for offshore foundation design, the first step is to have a thorough understanding of the soil condition through what we call the marine site characterization. So this process is the understanding of geological, geotechnical, environmental, and also meta-ocean condition in relation to the target field development. So thus we can like have a optimal site selection, design, and the installation of the facility, while in the meantime to be able to effectively mitigate the geohazards. So we sometimes we either try to avoid the geohazards, and on occasion we cannot like avoid these geohazards, and we will have to design by the kind of to using the mitigation measures to consider these geohazards. Sorry, let me see. Sorry, my mouse is very sensitive, so let me make sure I don't. Okay, so in the industry, typically like we use what we call the phased diagnostic and also geodata integration approach to develop a ground model. So we also typically use some kind of like the GIS tool, so we can develop like a kind of like the comprehensive ground model, which will like which will be able to identify, map, and assess the geotechnical constraint and also the existence of geohazards. So as shown here for the ground model, we normally need to consider like the public domain available data, meta-ocean data, and also like the geophysical, geotechnical data, and also like considering our previous site like experience. So with all these, then we use it for the foundation engineering analysis. The geophysical data and the geotechnical data are typically acquired through geophysical site investigation and also geotechnical site investigation. So here showing like for the geophysical site investigation, we normally utilize like an echo sound side scan sonar, sub-bottom profile, 2D or 3D multi-channel seismic reflection survey. For geotechnical site investigation, we normally using like the in-situ testing, such as CPT, kind of a cone penetration test, like a PS logging and in-situ wind shear. And also we can do like the sampling and the laboratory testing to obtain the geotechnical data and also like the soil property. Sorry, my mouse is today is really sensitive. Let me see, make sure. So, so this table like the list the typical like the geohazards we normally observed for marine foundation engineering. So typically like we can see like the submarine slope instability, sea floor roughness, shallow gas, shallow water flow, mud volcano, other form, like also sometimes we see like buried bold, buried channel, gas hydrate, also sometimes like the local rock outcrop, seismic activity like earthquake, also like the UXO. So basically like this type of geohazard typically can be identified through like the geophysical site investigation and the geotechnical site investigation. So basically like from the geophysical data, geotechnical data, like we can observe, we can identify these geohazards and consider this in like the facility, offshore facility siting and also the foundation design. So for offshore foundation design, basically two aspects needed to be considered. First, we need to ensure the foundation will have sufficient holding capacity. So basically, in industry design guidance such as API, American Petroleum Institute, or ISO, International Organization for Standardization, they have the standards to specify what is the minimum required factor of safety through the entire design life, based on different the environment loading the category. So also for the holding capacity analysis, we need to consider as I'm showing here the different type of environment loading conditions such as static load, cyclic, and also dynamic loads. Also for foundation design, we need to consider the installability. So even if for example in the case the foundation will have sufficient holding capacity, but what if the foundation cannot be installed to the seabed to meet the target depths? So basically the installability, and also whether the foundation can be safely retrieved, removed in a case if the foundation needed to be retrieved. So for example, if we if we install suction pile, but there is kind of we cannot meet the vertical, typically if the foundation has a little bit of tilt, then it's not meet the design, meet the installation tolerance, then the foundation needs to be retrieved. So so the design also need to consider in this the special event. For example, if the foundation to be removed 24 hours after installation, then this the factor need to be considered the soil setup process, the skin friction increase, so needed to be considered in the foundation design. Also, as shown in the slide, so the actual the one thing for the offshore foundation design is sometimes we have to dealing with very complex kind of site condition, such as for example the site is composed of the interlayered kind of a profile, having sand, clay, silt. Also if we meet the difficult soil type, the one in the article by Dr. Jack Vasquez and also Dr. Federico. So basically they have an article in the same issue talk about the pile driving in granite soil. So granite soil is also one type of difficult soil type, carbonated soils. So in the design, we need to consider all these kind of soil condition, consider this strength and isotropy, strain rate. Also for sand, sometimes they can be the fully drained behavior, but if the load is pretty rapid, like a stone load, it could be fully in the partially drained or even undrained condition. And also again, as it's showing here, cyclic degradation due to these wave loads. So basically the soil the stiffness and the strength going to be reduced because of the nature of the cyclic loading. So all this needed to be considered and incorporated when we do the foundation holding capacity analysis. Also another thing is we need to consider the realistic failure mechanism. So different foundation type will have different failure mechanism. So this will have an impact on the soil laboratory testing. Because for example, if the soil failing in a plain stream mode or failing in active, soil pressure like this. So we are looking at the different aspect of the failure mechanism and also different laboratory testing type. Also for the offshore foundation, because of this repetitive loading of waves and the currents, so the fatigue consideration is very important for offshore foundation. So we will also have to evaluate the fatigue life, the fatigue behavior. So in respect to the assessment of offshore foundation installation, like the behavior, we need to consider like first whether like the driving force for installation can overcome the soil resistance, and also during the installation process, we need to evaluate the structural integrity. So basically, like we need to prevent, for example, installation buckling, like for suction pile design, we need to consider like during the installation because of the suction, because this is unsupported like a column. So the installation buckling will need also to be checking. And also for installation, as showing here, we need to consider the setup process. So during the installation, like the soil will be disturbed, but as time goes by, there will be like a consolidation process, the excess pore pressure dissipation. So the soil strength can be partially or sometimes fully regained during the setup process. So these all need to be considered in our installation assessment. So offshore foundation, like as showing here, they can be installed through different modes, such as like by its own deadweight penetration or impact or vibratory pile driving, suction, dynamic penetration, drag embedment or direct embedment using a pile follower or helical pile. Helical pile actually is very common for onshore application, and it's started to get more application in the offshore environmental. So for like gravity-based structure, basically it's showing here, typically it's located in water depths less than 40 meters. For the gravity-based structure, it's just installed by its, basically it's relying on its own weight to provide like the capacity. So it's very simple to install and operate. Depending on the site conditions, sometimes we have to do some kind of seabed preparation and also utilize scour protection. Also showing here is torpedo pile. Torpedo pile is basically it's sort of a dynamic penetration through a free-falling pile. So torpedo pile actually is used a lot in offshore Brazil, like Petrobras. So here also showing like some images of the offshore foundation type. So basically like the top row here is showing a driven pile. So driven pile basically is very, very, very common like in offshore like geotechnical engineering. So basically for driven pile, like we can either using like the impact, like a hammer, or we can use like the vibration method to get the driven pile through the target penetration depths. So for driven pile, we also need to consider friction fatigue, which is a degradation of the shaft resistance because of this repetitive hammering, impact, and also setup process. This one showing here is a suction pile. So basically, suction pile is installed by the combination of pile soft weight and also suction. So suction pile typically used a lot in clay and also sometimes also in sand. So the installation behavior of suction pile in sand is a little bit challenging compared with clay. So the installation of suction pile in sand, we need to consider the interaction between the shaft and also the tip. Also, we need to consider like because they have this seepage, so they have this upward hydraulic gradient, which will cause the effective stress reduction inside the pile. So the one showing in the right of the second row is drag embedment anchor. So as showing here, the drag embedment anchor is basically they been like dragging horizontally with a chain or wire rope to the ground. Basically, it consists of a fluke attached to a shank. So basically, drag embedment anchor like they are suitable to support horizontal loads. So they basically mainly utilize it for catenary mooring system, which is only have like the horizontal design loads applied to the anchor. So the fourth row picture, like the picture below is showing the vertical loaded anchor, which it's a variant of drag abandonment anchor. So the vertical loaded anchor, like through this shear pin release mechanism, they actually can allow the fluke to rotate until the load basically perpendicular to the shank. And so basically the vertical loaded anchor, they can support like the vertical load. So for all these like the anchor like types, like drag anchor, vertical loaded anchor, the anchor trajectory and the anchor penetration depths are very important to be determined to estimate the actual in situ holding capacity. And also here also showing like the list like the suction embedded plate anchor. So this like all we call it the SEPRA. SEPRA actually is a patent of the Intermo. So typically like the SEPRA is mainly the target for soft clays. So they're using a suction pile as a follower, and then to so once to deliver the plate anchor to the target depth. And also the suction follower can be retracted, so it can be utilized later for different site. Also here showing like the monopile. So monopile actually is a very common like a foundation type for offshore wind turbines. So basically for offshore wind turbine compared with like the oil and the gas foundation type, they have a very strict like deformation, like rotation, criteria. So for the monopile foundation, typically currently for the industry, we utilize it to water depths up to 60 meters. So for the monopile foundation design, is an important portion is to understand the interplay of the foundation stiffness and also the natural frequency. For offshore drilling rigs, the Spartan foundation is very typical. Spartan foundation basically is a saucer-shaped foundation. It can penetrate to several tens of meters. So the Spartan foundation, basically, the penetration process, it's like the effect of Spartan geometry and also meta-ocean condition, the holding period, the preloading sequence, and also sometimes what's the existence of previous footprint, because also sort of like the structure Spartan interaction. So if we have previous footprints or if we have nearby foundations, they could cause some kind of interaction issues, causing the shear strength reduction, and then to have to compromise the Spartan foundation capacity behavior. Also the last not least in this example showing here is the helical pile. So helical piles basically, as we mentioned before, is pretty common for the onshore geotechnical engineering. So helical pile typically utilize torque and axial force to install the pile to the target penetration. And compared with the driven pile impact hammer, it has the reduce the underwater noise. And also helical pile can be utilized in both sands and clays, have pretty good geotechnical capacity efficiency. The isolation torque is sensitive to the pitch of the helical piles. So as showing in the previous slides, we have quite a few offshore foundation types to be selected when we start the design process. So the basically what we call the KPI, key performance index of the offshore foundation, it's kind of we need to consider the foundation holding capacity and the design condition. Basically, we need to consider the capacity efficiency. The capacity efficiency is defined by the capacity divided by the foundation weight. So, and also we need to consider whether the foundation can be installed to the precise like the location. So for example, like we have like a suction pile, they have a very good like the behavior in terms of to reach the precision of positioning. However, like a drag anchor, drag embedded anchor, actually it's kind of like they will difficult to put the anchor in a precise location. I mean, so sometimes it's difficult to reach. So they maybe have some kind of offset from the target location to final installed location. So drag anchor, like I mean, considering this aspect, the suction pile will have more, will have better behavior compared with drag anchor in terms of the precision of positioning. And also we need to consider the isolation cost, isolation efficiency, and also they maybe have a potential loss of embedment. So we may, like at the end of insulation, the foundation may be reach the final penetration depths. However, like due to the design loss, they may have, for example, due to the cyclic ratcheting. So we may lose some kind of like the embedment depth. So could lose like the holding capacity. So all this needed to be considered, and together with like the soil profile constraint. This actually is very important. So it's showing like suction pile. Sometimes it's difficult to be installed in a thick chunk of sand layer. So when we see the site has this type of the soil profile, soil like the stratigraphy, then we will have to rule out the suction pile, like the foundation concept. So the actual, like the final product of offshore foundation type is a combination of many facts. Yeah, like the site condition, the capacity, efficiency, the precision of positioning, installation efficiency, installation cost. So basically, this figure here is showing if we look at the 40 meter by 20 meter vessel deck, what's the relatively size? So like of different foundation type, like these vessel trips. So for example, the 40 meter by 20 meter, we can hold 12 drag anchor, but we can only hold 2 gravity anchor. So for a large, for example, for a large offshore wind farm foundation, they will need like lots of foundations. So we actually had a design. They may need for a large offshore wind farm, they may need 150 like anchors. So if we use 2, if we use gravity anchor, so one vessel can only hold 2 gravity anchors, then we will have to do multiple vessel trips, and this is going to definitely going to increase the installation cost. Okay, so now we move to our last point. It's like the foundation technology advancement. So basically, like because of the energy transition needs, and also like the offshore like facility move to deeper water, and also move to this what we call the like the challenging soil types, like groundnut soil, like the carbonate soil type. So we need to have like the innovation. So one thing is for this technology advancements is like we need to increase geotechnical foundation design like practice. So such as to incorporation of the whole service life loading and the geotechnical capacity evolution. So basically, we need to consider like the for example, consolidation hardening effect due to this long-term process and this corresponding gain in holding capacity, and also in the industry, sometimes we use like what we call the hybrid foundation, so which are the combination of different foundation types, such as mud with pin pile or suction pile with. So this hybrid foundation, like sometimes they can be utilized to improve the load bearing capacity and also cost effectiveness. Also for the pile driving, as we show in the previous slides, in contract to the impact hammer, which actually causes like the loss of underwater noise, and also like the stress to impact the fatigue behavior. So currently, like in the industry, we're using like the vibratory hammers, so which significantly reduce the underwater noise and also reduce like this fatigue stress. Also like not just like the driven pile, actually for the large diameter bucket foundation, currently they are kind of like a research like a project to consider using this vibratory installation in combination with the section to install like the large diameter bucket foundation. Also like another thing is like now they have new innovation anchor concepts. So the example showing here is what we call like the deeply embedded ring anchor, which is a pattern actually from the deep anchor Deep Anchors Inc. company. So it's founded by one of the co-authors, like Dr. Chuck Albany and also Dr. like Junho Lee from Texas A&M University. So basically, they derive deeply embedded ring anchor concept. So they utilize the flower, the pile flower, and also like basically like caisson. So a combination. So the flower like basically like can like make like this plate anchor like a plate to reach the deep penetration, to utilize the strong soil at the deep. So this like the DIRA can be utilized in various soil type, and like also can be utilized for the multi-line potential, can hook up multiple mooring lines. So which it's a good feature for the floating offshore wind. Yeah, so typically for DIRA, like the L over D, like this length to diameter ratio of this basically this caisson here is about 2, and this like caisson by utilizing the follower, this like this skirt caisson can be installed about 5 to 15 times of this diameter. So and also another like the new anchor concept is the helical pile based system developed by the Triton Anchor. So for this like the helical pile based system, they basically utilize like the 9 helical piles combined with this caisson skirt as a module system. So basically like this helical pile based system like can provide like basically like good capacity efficiency, and also have a minimal installation noise. Also for this helical pile based system, like there is no proof of loading test needed. So from the installation torque can determine what's the actual in situ capacity. So I promise this is the last slide. So just to sum up, so basically like as kind of like to meet the energy transition need. So the innovation is the key. Will lead the way. So basically the innovation going to also like through the close cooperation between researchers and the practitioner. Also like through like the close like like the working relationship with the industry partner, also with regulatory. So to get the regulatory approval, there are key steps to commercialize the innovative offshore foundation concepts. So they will. So first, people have the new concept coming up, but they will go through different phases, kind of through a pretty long process to get it finally commercialized to be utilized in the industry. Yeah, so this basically sum up the introduction of this article. Thank you for your time. So I'm going to stop sharing. Yeah.
Thank you, Cheyenne. That was a very, very thorough description of the article, and kind of gives some information about some of the other articles that are in this issue of GeoStrata as well. But I think one of the things that is recognizable from this is that, a lot of this practice, or some of it, I should say, is similar to, on-land geotechnical engineering, but a lot of it is very specialized, kind of pushing the boundaries of the technologies that are available for foundation design and construction. And I'm just kind of curious, how did you first get involved with this very specialized application of geotechnical engineering? What's your story, Cheyenne? How did you start here?
Sure. So I think first I want to give some sort of like a brief introduction for myself. So I actually came to the States in 2000. So I went to first I studied 1 year in Ohio and then transferred to Texas A&M University. So 2000. So basically, like in A&M, like I actually like so we actually had a course taught by Dr. Damurf, like called like the Offshore Foundation Design. So Dr. Damurf sort of is like the idol I always look up to. So he basically is sort of people call him like the godfather of the offshore geotechnical engineering. So and he's also distinguished member of the ASCE. So basically, in the course, he sort of opened a door for me to kind of showing this kind of like the soil cyclic behavior and also foundation design, like different performance, numerical modeling. So I think like basically his course sort of like make me feel kind of brought up my interest in this subject. Yeah.
Thank you. Hey, before I forget, I need to remind everyone that we encourage you to ask questions, and if you have any, please type them into the chat, and they'll get forwarded to me, and I can sort through them and ask those questions, at the end of this presentation. So Cheyenne, given that explanation, what do you think is the most challenging aspect of offshore work?
So I think as shown in my previous slides, so for offshore foundation design, basically we are dealing with like actually in lots of scenarios we have to dealing with complex loading condition and also like challenging soil like side condition. So like showing there, like so sometimes if it's coconut soil, so they have some kind of special kind of features need to consider, and also because of the environmental loading, like we have to consider like the cyclic degradation, like if it's an earthquake, like risk, also like this seismic dynamic soil properties also needed to consider. So offshore foundation design, we normally like kind of have lots of technical challenges to deal with, and also because everything is beneath the water, so like it's not a very kind of it's not a very kind of like compared with onshore sometimes you can basically sort of like a more in interaction, I would say, that process. So like I would say offshore geotechnical engineering has more, I mean, at least in my opinion, has more unknowns, so more uncertainty. So basically you have to consider and also another thing is the offshore facility, they are also pretty expensive, and also they could cause some kind of like a if there is oil leaking, they may even cause the disaster for human life. So basically, so they are also carrying. So for the designer, also carrying like a bigger responsibility. Yeah, I mean, which is similar to onshore foundation design. Yeah. So basically, I think it's all for civil engineer. Like you need to keep in mind. Yeah.
Thank you. Yes, health and safety is always very important. I'll move on a little bit to talking more about like the selection of offshore foundations, which was a big part of your article. And you did describe, you have a nice table in there showing all the different types of geohazards that are unique to offshore geotechnics. I mean, how do you go about detecting, these different types of geohazards at a particular site?
So basically, so for example, like this, when we so typically for the operator, they wanted to have a new development. The first step is like the geophysical survey. So basically through like the seismic reflection survey and archive sound. So and the other tools. So we will acquire geophysical data. So the geophysical data can be a very good source, like a resource to identify like the geohazard like existence. So because from the geophysical data, you can see whether there are some kind of like this seismic like amplitude nominal. So basically like like they will have a different behavior, and also from geotechnical like the investigation data can also be utilized. So for example, for the shallow gas, sometimes when we drill a borehole, we can actually even see like this gas bubble. So basically, which is a clear identification of the shallow gas existence, and also like the shallow water flow. So basically, yeah. So this actually like highlight the importance to have a thorough like the site investigation to acquire sufficient data. So the operator and the designer, installation contractor can be aware, like identify and map the existence of the geohazards.
Thank you. Moving on, you did mention, all of the different foundation types. Just generally speaking, what types of considerations are there when you're selecting the foundation type? Is there one that maybe it's your favorite, and if you can do that one, you would always use, say, driven piles or something, and then given conditions, you might move on to a different one, or is it more of like just a unique situation at every site?
I would say like a case by case, because it's similar to in my previous slides. So basically, like the selection of offshore foundation design, first we need to consider the site condition. So, and also consider like the capacity, like efficiency, and also installation behavior, like installation cost. And also, as we showed before, like whether there is a risk of loss of embedment. So all these, I mean, typically, for example, for designer, for the operator, for example, because drag embedment anchor typically in terms of installation cost is pretty cheap. So normally, if it's a catenary mooring system, so the kind of like the drag embedment anchor normally and will be kind of a very common choice for designer. And another one, like I would say, like operator typically favorite is like the suction pile. Suction pile is basically being widely used, especially for clays, for the softer clays. So basically, it's kind of like as we showed before, like the suction pile, like we will know exactly what is the final installation, like the location. So basically, like so it's very precise for the final depths and the location, and also compared with driven pile, it has more like the kind of it's relatively a little bit cheaper. So like. And also for driven pile is also pretty common choice, but the driven pile has difficulty in terms of dense sand, hard layer, and also the like the rocks. So there are some kind of like a case study, like a driven pile can driven through like the soft rock, but it needed like a very experienced geotechnical engineers. Such as like one of the courses, like Dr. Bob Stevens. So basically, he's a world well known like the drivability like expert. So he he had lots of case studies showing he was able to make this like a pile driving through like the hard soils, but this needed lots of experience, like yearly experience. So typically this the one showing a typical foundation types, very common, but it's like a case by case. So basically, for example, if we have a thick sand layer, then we know like a suction pile is a no-go. So you will have to, analyze the site specific like loading condition and also the site condition. Yeah.
Thank you. Moving on a little bit here. You did mention a lot of the different tools that you use for site investigation, including, geophysics, and then there's some more techniques that involve sampling and in-situ testing, etc. I mean, just to put it in perspective, I work on smaller land jobs, and often our site investigation takes like maybe a week. How long do you spend for a site investigation for an offshore project?
Yeah, so for offshore site investigation, I mean, like it also depending on like the complexity of the site condition. Like if the site, for example, is benign clay, it will go smoother. If it's an interlayer, it will be taking more time, and also it's going to depending on the weather conditions. So sometimes if there is no window, for the operation so basically we will have to, so the vessel will have to stand by. And generally speaking, the geophysical site investigation will take a little bit less time. We talk about maybe 1 or 2 months. The geotechnical site investigation also, again, depending on the scope. For example, the geotechnical site investigation, if we are looking at the multiple, quite a few soil boreholes, CPT, it may take a longer time compared with if we looking at the jackup, like the rig, we only look at like one soil borehole, 3 CPT, then will be like a short time. But I would say typically like at least the time frame we normally deal with at Fugro, we talk about geotechnical site investigation, we talk about the 2 to 6 months or even a little bit more. Yeah, so it take a lot of time, and also when we finish the field work, and then for the laboratory testing, we also take sometimes 6 months or even more. So before move to the foundation design, just to get the ground model development for the site characterization, we are talking about a year or sometimes even longer period. Yeah.
Oh, great. That's a good answer. A lot of times, and I'm going to jump ahead a little bit, but in our realm, a lot of times the owner, he wants to know what the foundation cost is going to be right at the very beginning, So I'm wondering here, at what point are you able to, in the planning process, are you able to estimate the cost of the foundation system?
So I would say like typically at the fade design, so basically it's the front end engineering design stage, because in the feed design, when typically like the operator will determine the technical feasibility and also like the economic cost. So because for the feed design, typically like we will like from the preliminary like the conceptual like a foundation type, then we're going to evaluate to choose like the foundation type suitable for the target, like the field development. So I think I would say at the feed design stage, we will have a pretty good understanding. I mean, of course, it's not like a rocket science. It could be varied a little bit later, maybe through the optimized final design stage or something. But typically at the feed design stage, we will have a good ballpark number. Yeah.
Well, since you did use the word design there, I want to move on a little bit and talk about, the design of offshore foundations. So starting, what kind or type of soil models are employed during design and analysis? Are you using very sophisticated constitutive models or something else?
Yeah, I think it's also basically also case by case. So for example, for the mud for the if the site condition is pretty benign, if we have like the uniform, like the for example all clay profile, and then like so typically we can use like, and also we are dealing with very kind of like uniaxial like load design loads. So we can use like the classical API, like API classical bearing capacity theory, but most of the cases we are dealing with complex like the interlayer and also 6 degrees of freedom combined design loads. So in that case, basically like the studies have indicated the classical bearing capacity theory based on the limited equilibrium approach is overly conservative. So we will have to move to numeric simulation using like the another different software like Plexus, another element software Plexus or another difference flag, or using the Abacus. Also like it also depending on your design loading condition, whether we are dealing with static, cyclic, or seismic. So basically like for example, if it's cyclic, considering the cyclic degradation, then you can using this kind of partially drained like the pore pressure accumulation model, like which is or like undrained pore pressure like a strain accumulation model, which is already implemented in practice. Also like they are like the UBC sand, like sandy sand. So all types of model, and in terms of like the consider like the seismic, like the soil liquefaction. So basically like a PM4 sand, the PM4 silt, like this complex constitutive model, we will have to utilize. So I will say it's also case by case. Yeah, it's no uniform answer.
How about to what extent is the observational method used during the installation, and are the designs flexible such that they can be altered as needed?
I think I think like basically for the onshore engineering, they're using like what we call the observational, like approach. So basically like we can inspect the inspect and like the monitor the design like at the time of construction. I think for this observational approach, like they have been utilized in offshore foundation design, but it hasn't been widely kind of like codified and kind of like hasn't been widely recognized. So sometimes like the design team is using this method, but they may not be fully aware. I think one thing is because this observational approach, like it's handled in offshore foundation designs because the conceptual issues, because we don't. I mean, like sometimes it's like first what's this kind of remediation, what's the measures, whether they are practical or not. Like I mean, compared with onshore engineering, like geotechnical engineering. So I think the answer will be it's being getting more and more utilized, but they haven't have the. I think there is only DNV GL 2012 guidance has mentioned a little bit this observational approach in offshore engineering foundation design. There are no other design codes like kind of formally codified yet, but we can definitely say the application in terms of especially phased offshore site investigation, and also for the anchor design, anchor sizing, such as even a driven pile. We can say this process So I think we can say it will get more widely like used in the future. Yeah.
Thank you. Well, I was going to move on to like durability and service life, but we did get two questions from the audience that actually related to that topic. So I think I'm going to follow the audience question. Sean McEwen is asking, in designing foundations for offshore structures, what are the typical design lives?
Typical design life, I think it's also, again, depending on whether it's temporary or permanent, kind of like a facility. So, for example, for the if it's temporary, like a mooring system, so we may look at several days or several months, like the design life. If it's permanent, I would say typically in the ballpark number, like 20 to 30 years, it's pretty common. So yeah, for in terms of the design life. Sorry, Ken, I think you are muted.
Thank you. I was, yeah. So as a follow-up, Sean, is it good to know that you allow for foundation removal at the end of design life? Do you address the removal methods with minimal risk? And do you anticipate changed geotechnical conditions near the foundations, throughout the service life? I guess that's more like three questions in one. I guess one is, do you usually think about the need to remove foundations, perhaps at the end of the service life?
I think it's also case by case. So I think most of the time, actually, I would say like at the end of design life to remove is not very common. Sometimes they will just cut it, cut it off below the mud line. So basically, they will keep it there. In our design, we typically the scenario when we do the removal analysis is like as we mentioned, if it doesn't meet the insulation like a tolerance, so or sometimes if it has like it cannot keep this vertical angle, like it has some tilt, typically because we normally most is allowable 1 degree, like the tilt. But sometimes in the installation process, it may, has more than this required, minimum required, then we will have to remove it. Yeah, I would say like the removal at the end of design life, like at the end of 30 years, I think it's not a very common practice, at least for my consultancy projects. Yeah.
Thank you. So we're kind of getting towards the end here. I'd encourage anyone that has any more questions to go ahead. But in the meantime, Cheyenne, in conclusion, what do you think the future holds for offshore foundations, and do you have any closing comments?
Yeah, I think just showing in my last slide, I truly believe like the technology advancement, like innovation is key, is very important, because as to meet this energy transition needs, so like and also actually we have new, like for example, for this like a floating solar, renewable, like all kinds of. So we are dealing with like the lots of unknowns, uncertainties. So we will need like the innovative like foundation type, and also like the technology advancement, also including like the design practice, like design methodology. We will have to achieve like the optimal like the performance. I mean, like in the past, sometimes in the past. So basically, like okay, like I think people have a bit of misunderstanding in terms of geotechnical engineering. They typically say, okay, if I have a sufficient, I put a big factor of safety, I don't need to go through such a comprehensive process. Typically, like sometimes we hear from people like geotechnical engineers, sometimes it's always being downplayed, be underestimated, because they were thinking, okay, I can just put a big factor of safety. But, So for example, for offshore wind, I mean, like the foundation cost, actually, it's a big component of the whole project. It's like typically it's 35% of the or more of the whole project cost. So you need to try to avoid the over conservatism. And also, like as mentioned, and also like we move to like the difficult soil type, difficult like the new frontier areas. So yeah, it's basically like the innovation and also using the combination of the like also using like the AI, artificial intelligence, geospatial modeling, all this kind of a tool to build a kind of to use this multidiscipline and the holistic approach to reach a sound and also cost-effective foundation design. So I think I think like the looking forward to the new technology advancement. Yeah.
Thanks. We just did one last question, and so I'll do this before we turn this back over to Brad. But Senhu wants to know if you can recommend, any design guidelines or textbooks that one could look at and study, for this specialty. I remember at the beginning you talked about a course that you took that got you very interested in this subject. Was there a textbook for that class that was good, or just maybe the course notes, or what should people see?
Yeah. I think unfortunately for Dr. Murph's course book, well, I think his course notes were not published in a textbook. However, actually, like Dr. Chuck Albany, like my advisor, he's also one of the course. He actually published a very good like textbook talk about the geomechanics of anchors, which I highly recommend. So basically, in that book, he actually discussed the different offshore foundations, like types, suction pile, drag anchor, this vertical loaded anchor, etc. In terms of like the design guideline, like as we mentioned, we have like the API, like basically is full name is American Petroleum Institute. So API have like various for geotechnical is like API 2GEL. It's basically sort of like our Bible in terms of the site investigation and the geotechnical foundation design. And also we have like ISO 199014. It's also talk about the site investigation on the foundation. So and in addition, like the ABS basically is American Bureau of Shipping. So ABS and also DNVGL, they also published a series of like guidelines. So for different type of foundations and also including like the pipeline design, riser, all these things. So yeah, so I think these are all like a good reference.
Thank you. And thank you for the contribution to GeoStrata with your article and for spending some time with us today to share your knowledge on offshore engineering. We really appreciate it. At this time, I'm going to turn this back over to Brad, who I think has a few parting comments.
Oh, I like that. I was afraid you were going to say they were wise words or something like that, because I don't know that they're wise. But that was a fantastic presentation. I like, we don't often have that kind of presentation on GeoStrata Extra where somebody gives a little intro into the field. So that was really good, because there are a lot of people who are not familiar with offshore and a lot of the terminology and stuff. So that was a really great way to start. For all our viewers, thanks for being with us today. We really appreciate you coming to all these live streams. I counted before we went live today. This is number 192 that we've done on the YouTube channel. So we're coming up on number 200 pretty soon. We'll do something special for that, I am sure. Again, make sure you read the October-November issue of GeoStrata. You can do that with the one that came in the mailbox to you directly, or you can go to readgeo.com and check out the current issue and all of our back issues there. So, Ken, great job with the interview. Xiaoyan, thank you so much for all this intelligence today and going behind the article. I hope it was fun for you guys. We really appreciate you doing this.
Thank you. Yeah, thank you, Ken and Brad, give me an opportunity to talk about like this offshore geotechnical foundation design is one of my passions. So I'm really happy to discuss. Yeah.
And you can tell. And like I was saying, the offshore community, there's something special about it. You guys are so devoted to what you do. It really comes through when you talk about it. So that was awesome. Thank you so much. For our viewers, again, of course, we've got a lot more great live streams coming up for you. The next one is going to be on Thursday, in just 48 hours from now. It'll be episode 1 of our 3-part Macaferry live series that we are doing with our friends from Macaferry this fall. You can see Lucas Martins from Macaferry presenting on their surface stabilization design software. You can register for that and all of our other upcoming live streams at our Eventbrite page. We'd love to see you back here again soon. Our producer today was Aurora Flieger, and we will see everybody on another Geo-Institute live stream very soon.